In this video, I'll explain some challenging cases in the classic RAG, Retrieval-Augmented Generation, process and why these cases can benefit from the integration of an agent-based approach. The first type of case is summarizing documents using RAG. The documents in question might be a single document or a large number of documents. If we use a traditional RAG, we need to extract all the chunks of information from the document and insert them into a prompt for summarization. However, this information is often too much to fit into the context. Therefore, in many cases, we cannot fit the entire content of all the documents into the context window. Additionally, in this scenario, the retrieval module must extract all the documents, which can be challenging. So, how should we handle such cases? There are a few approaches. The first method is called an iterative approach. For example, given a document, we first create a summary for this document. Then the summarized information might look like this. Based on the results of this summary, we incorporate the second document and create a corresponding summary. This process continues iteratively until the final document, allowing us to obtain a complete summary of all the documents. The second method is quite similar to the first one, but it employs a hierarchical structure. That is, if we have many documents, we first create a summary for each individual document. Then, we continue summarizing at higher levels. This method is referred to as hierarchical summarization. The second type of case involves comparative scenarios. For example, on an e-commerce platform, a user might ask a question like, I want to compare product A, product B, and product C, and then request a summary of the comparison results. In such situations, the classic RAG cannot provide a reasonable answer. So how can we address this? One common method is to decompose the query into 3 separate queries, since we want to perform a comparison. First, we need to understand what A, B, and C are, as well as gather detailed information about them. Therefore, the first step is to extract information about products A, B, and C. When extracting, we focus on the dimensions that the user cares about and then create a corresponding summary. This process involves an intermediate step to facilitate the comparison. The third common case combines semantic search with statistical analysis. For example, the question might be, how many companies in the current market that are active in the field of large language models are publicly listed? For this question, the first step is to perform semantic search. We use online information to search for companies that are currently most active in the large language model field and extract a list of these companies. For example, we might find 20 to 30 companies. Based on this list, we then calculate how many of these companies are publicly listed. For this type of problem, a multi-step analysis is required. The first step involves performing the search. The second step involves statistical analysis. The second step often corresponds to tasks like NL2 SQL, which is text to SQL. After obtaining the list of companies, the next step is to retrieve the corresponding statistics from a database. The fourth type of case involves complex queries. For example, a user might ask a question that first requires analyzing the themes present in a document. Based on these themes, the task would involve searching online for related content, organizing this content into a tabular format, summarizing it, and then providing insights. Such queries often consist of numerous subtasks. To address them, the query must be broken down into different stages of tasks. For these cases, classic RAG cannot process the query in one step and provide an answer. Instead, there needs to be a multi-step logical process. If a certain step is not handled well, it might require going back to adjust the previous step. The essence here lies in breaking a complex task into smaller, manageable tasks. For these types of problems, they can also be handled within an agent-based framework. You can think of RAG itself as a small module, and the agent controls how these small modules interact. In essence, the agent operates on top of the RAG system. If we combine the agent concept with traditional RAG, we call it Agentic RAG. Agentic RAG is still in an early stage of development. Many tools are exploring ways to integrate this concept into existing RAG systems. Of course, we can also use a more direct approach. When a query is received, we identify its type and then create a dedicated workflow for handling each type of query.